Here's an inelastic collision problem that begs for a solution by way of momentum conservation. A 5-kilogram fish swims at 1 meter per second toward and swallows a smaller 1-kilogram fish at rest. Find the velocity of the larger fish immediately after lunch. Ignore the effects of water resistance. Since there's no outside forces acting on the two-fish system, we know that the net momentum before lunch will be equal to the net momentum after lunch. Following the physics, the initial momentum of the large fish is 5 kilograms times 1 meter per second. Add this to the initial momentum of the small fish, which is 0. After lunch, the net momentum is the combined mass times v, what we're looking for. Continuing, and canceling kilograms, we see that the velocity after lunch is 5.6 meters per second. This velocity is in the same direction as the initial velocity of the large fish. We employ the conservation of momentum and come to a solution. Yum! Suppose the small fish is not at rest but swims toward the left at 4 meters per second. Find the velocity of the larger fish immediately after lunch. Again, ignore the effects of water resistance. As before, the net momentum before lunch equals the net momentum after lunch. We have the initial momentum of the large fish plus the initial momentum of the small fish with velocity equal to minus 4 meters per second. And after lunch, we have the combined mass times the velocity v that we're looking for. So we see the initial momentum is 5 kilograms meters per second minus 4 kilograms meters per second in negative direction relative to the large fish, which equals 6 kilograms times v. Combining terms and canceling kilograms, we find v equals 1/6 meters per second. What happens here is the negative momentum of the small fish effectively slows the large fish after lunch. Suppose the smaller fish was swimming twice as fast, at 8 meters per second. Then we make use of our prior calculations, changing minus 4 meters per second to minus 8 meters per second. Here we see the final velocity is minus 1/2 meter per second. What's the significance of the minus sign? After lunch, the two-fish system moves backward toward the left. Yum yum physics, at least according to the large fish. I want to leave you with a question. How fast would the small fish have to swim before lunch to halt the large fish in its tracks? That is, what speed brings the net momentum to 0? Until next time, good energy.